Here I'm going to show you how to plot some points or ordered pairs, starting with the first one, negative 3, 2. This coordinates tell us to go negative 3 in the x direction, which is left 3, and positive 2 in the y direction, which is up 2. So from 0, 0, the origin, we're going to go negative 3 in the x, left 3, and positive 2 in the y, up 2, and that will be where our point is located. So roughly, left 3, up 2, about there. Next we're going to do 4, 5. That means 4 in the x direction, right 4, 5 in the y direction, up 5. So right 4 and up 5 will put us about here. Next we have negative 1, 0. Negative 1 in the x direction means we're going to go left 1. 0 in the y direction means we're not going to go up or down at all. So starting from 0, 0, we're going to go left 1, and then we're not going to go up or down, so we're going to be stuck there at left 1. So this is the point negative 1, 0. Lastly, we have negative 5, 0. That means negative 5 in the x direction, left 5, and 0 in the y direction. That means we're not going to go up or down again. So starting at 0, we're going to go left 5, and then up or down 0. That means we stay there. And that will give us the point negative 5, 0. And that's how you plot points in the xy plane. And lastly, if you have points and you want to come up with the coordinates, that's also a useful skill. So if we start at this point, for example, how do we get here from 0, 0? Well, you always go left or right first. So first we'd have to go left 2, and then we'd have to go down 3. Right? So from here, left 2 is negative 2 in the x direction. So I'm going to enter negative 2 for the x coordinate. Okay, so again, from here we go left 2 and down 3. Down 3 means we're going to go negative 3 in the y direction. So our y coordinate will be negative 3. So that is our first point. This one right down here would be negative 2, negative 3. And for this one, starting at 0, 0, we're not going to go left or right at all this time. That means our x coordinate is actually going to be 0, because we're not going left or right. But then we have to go up 2, which is positive 2 in the y direction. So our y coordinate is positive 2. So this point here has the coordinates 0, 2. Over here, we'd have to go right 5, up 4. Right 5 means 5 in the x direction. Up 4 means 4 in the y direction. So this point has coordinates 5, 4. Over 5, up 4. And this one is over 5, down 4. So it's still going to have 5 for the x coordinate, but since we're going down 4, that's going to be a negative 4 for the y. So that's how you use a graph of points to come up with the equation, or sorry, the coordinates for those points. Our first method for graphing a line will be picking values for either x or y, plugging them into the equation, and solving for the other variable. So here we picked 3 values for x, and we're going to plug each of those in for x and see what we get for y. I picked these values pretty arbitrarily, but in general I like to pick something negative, I like to pick 0, and I like to pick something positive, just to get a big picture of what's going on the actual line. So we're going to start with negative 2. We're going to plug in negative 2 for x, and then we're going to solve for y. Now y equals 2 times negative 2 will be negative 4, and negative 4 minus 3 will be negative 7. So our first point, we figured out when x is negative 2, y is negative 7. If we go through and plug in 0, this one's pretty easy. Y equals 2 times 0 minus 3. 2 times 0 is just 0, so you get y equals minus 3. So there's our second point, 0, negative 3. And we could probably do this in our head. If you plug in 2 for x, you'll get 2 times 2, which is 4, and 4 minus 3 is 1. So when x is 2, y is 1. Those are our 3 points. Now that we have our 3 points, we can just plot them and basically draw a line through it. So we'll start with negative 2, 7. That means we're going to go negative 2, so 2 to the left, and negative 7 down 7. So our point will be right about here. Then we have 0, negative 3. So that means 0 left or right, so 0 in the x direction, we don't go left or right at all. And negative 3 in the y means we go down 3. Something about there. And then 2, 1, that means we're going to go right 2 and up 1. So our last point, oops, not great. There we go, right about there. So you can see how these fall in a perfectly straight line, which is the point. And if we try to draw a straight line through them, roughly, let me just There we go. This is the line that represents the equation y equals 2x minus 3. The x-intercept is the place where your graph crosses the x-axis. If we're looking at this line, our x-intercept is 5, because that's where the line crosses the x-axis. The y-intercept is the place where the graph crosses the y-axis. Our y-intercept would be 2 here. If you want to solve for your x-intercept, the key is that whenever you're on the x-axis, y is automatically 0, because you haven't went up or down. So if you want your x-intercept, you're going to plug in 0 for y, and then solve for x. Similarly, if you want your y-intercept, the key is on the y-axis, x is always 0, because you haven't went left or right. So if you plug in 0 for x and solve for y, that'll give you your y-intercept. Here we're going to find the x and y-intercepts of this equation. To find the x-intercept, we're going to plug in 0 for y and solve for x. So if we plug in a 0 right here for y, 2 times 0 is just 0, so we just get negative 3x equals 6. And then we'll divide both sides by negative 3 to get x equals negative 2. That is our x-intercept. That's the place where the graph crosses the x-axis. Similarly, to find our y-intercept, we're going to plug in 0 for x this time. So negative 3 times 0 plus 2y equals 6. This piece goes away, so we get 2y equals 6. And then if we divide by 2, we'll get y equals 3. So that's the location where the graph crosses the y-axis. We can plot these now and graph the line. So we had negative 2 was our x-intercept. That's technically negative 2, 0, because we plugged in 0 for y. And then 3 was our y-intercept. That's technically 0, 3, because we plugged in 0 for x. And if you draw the line through it, you get that equation, or that graph. So this graph represents this equation of the line. The slope of the line is how it's leaning, and it's one of the most important characteristics of a line. And to figure out how it's leaning, what we can do is find any 2 points on the line and figure out how far up do you have to go, up or down, to get from one point to the other. We call that the rise. And how far left or right do you have to go to get from one point to the other. We call that the run. And if you take the rise and you divide it by the run, you get what we call the slope. There's a formula called the slope formula, and here it is right here. And it basically takes in 2 points, so like x1, y1, and x2, y2, and it spits out the slope. So this is the formula you use if you have 2 points and you want to come up with the slope. Here's an example of using that formula. They want us to find the slope of the line that passes through these 2 points. We know our formula. The first thing I would do, just to make sure you don't confuse things, is label these points. I'm going to call this x1, y1, and call this x2, y2. Just because there's a lot of pieces in the formula, it's easy to mix up where one goes. So on top, y2 minus y1 will be 3 minus 4. On bottom, x2 minus x1 will be 1 minus negative 2. Be careful about minusing the negative there. 3 minus 4 is negative 1. 1 minus negative 2 is actually 1 plus 2. So we get negative 1 over 3. That is the slope of the line that passes through these 2 points. You should also be able to look at a line and come up with the slope. The way we can do that is, again, identify any 2 points and then count the rise over run, how far up or down, how far left or right, to get from one point to another. So for this first graph over here, let's find 2 clear points. So for example, it looks like it's passing pretty clearly right here, and it looks like it's passing pretty clearly right here. So to go from here to here, how far up and how far over? Looks like we have to go up 1 and over 1, 2, 3. So I would say that has a slope of 1 over 3, because between any 2 points you have to go up 1 and over 3. Notice I'm looking for points that are right on the grid, because like this point here, I don't know exactly where it's at, so it's hard for me to count up and over. If I find something that's exactly on the grid, then I know I can go exactly up 1, over 1, 2, 3, and there I am. For the same idea for the second graph, looks like there's a point here clearly, and there's another point, let's see, here. Okay, so from here to here, we could go down 1, 2, and then right 1, 2, 3, 4, 5. So down 2 and right 5. When you go down, that's negative in the y direction. So our rise is actually a negative 2. And since we went right 5, right is positive in the x direction, so we'll just do over a positive 5. If I were to count left for my run, then it would be negative. So keep in mind, down is negative, left is negative. Up positive, right positive. You can also graph using a point and a slope, which is probably the best way to graph, and we'll be doing that a lot in the future. Start with your point though. It says we pass through the point 2, 1, so that means we're going to go right 2 and up 1 and plot a point right there. And now it says with slope 2/3. So remember, the slope is telling you between any 2 points how far up and over to get to another point. So we have a point already. I know that if I go up 2 and right 3, rise over run, I'll end up at another point. So from this point, I should be able to go up 1, 2, and right 1, 2, 3, and that will be my second point. Right about there. Right, so that's how you basically graph using 2 points, and then I'll just kind of finish it off with the line here. That's going through, sorry, not 2 points, a point and slope. There's my point at the bottom, and using the slope, I found that second point. So here is our line.